Hey everybody, today we're going to be talking about impact transients in runners. An impact transient is a disruption in the normal force distribution of the lower extremity upon heel strike or upon initial contact for a runner. First, we're going to describe a more normal or ideal distribution pattern. So you'll see this force over time graph is going to start at our initial contact and go through our whole stance phase, which will be approximately 0.2 of a second. As the foot hits the ground, you'll see the gradual rise of force, ending at a peak when our body weight is directly underneath of us here. And then it'll transition as we go into our late stance or toe off to zero amount of force. On the right side, we're going to be demonstrating our impact transient. So you can see our overstride or our heel strike is creating this distance between our foot and our trunk. The graph is going to show the initial contact at the heel. We're going to see the gradual rise that we see on the left, but because we are landing too far in front of us or on the heel, you'll see that the cushion of the heel braces our impact, and we see this slight dip in our force distribution pattern. And then as we roll into our full body weight, we see an immediate spike back up to our normal amount of distribution. And then our typical drop that we saw on the left-hand side as we go into our more toe-off position of our gait phase, where there's just zero force distributed. Impact transients are dangerous because, as you can see, there's this rapid decrease in muscle activation followed by a rapid increase in peak activation. This leaves our joints and muscles a little bit vulnerable because there's this period of slight relaxation at a moment when we're in full weight bearing, in addition to the high forces of gravity and impact. Some things that increase impact transients are heel strikers or highly cushioned heels, as well as overstriders when you land too far in front of you. This then leads to a highly debated topic of which is better, a heel strike or a forefoot strike. The research is very conflicting in terms of which causes or prevents injuries, but what we'll do here today is talk about the definites. A heel strike promotes a higher dorsiflexion moment, and a forefoot strike promotes a higher plantar flexion moment. These both provide a very different stimulus for the arch, plantar fascia, and lower leg. Moving up the chain, a heel striker will experience a lot more stress to the knee, hip, and back because it's creating a higher demand above the ankle. Whereas a forefoot striker, it's a bit more distributed evenly through the foot, ankle, and lower leg stabilizers. As we previously mentioned, a heel strike creates a higher impact transient, while a forefoot strike creates more of a uniform curve of force distribution. We find that heel strikers have less activation of the foot intrinsic and extrinsic stabilizers, whereas a forefoot striker, we see a high level of activation into the foot. A heel striker tends to be on the ground longer, creating a longer stance phase, whereas a forefoot striker promotes a bit of a higher cadence and less stance time. So as always, it depends. When you're looking at forefoot strike, heel strike, and impact transients, it's very difficult to prove causation of injuries. But what we do know is that overstriding is bad. Overstriding can exacerbate or enhance some of those detriments of a heel strike. This tends to be the problem with a lot of the current research when debating forefoot versus heel strike, is because they're not taking into consideration what part of the ground the foot is hitting in. But the two diagrams here are showing that you can land at a heel strike or a forefoot strike, but still be hitting the ground in the same position. This can decrease or at least control some of the detriments we'd previously mentioned about the heel strike. An improved contact position will promote better braking forces and deceleration, a decreased impact transient, increases our cadence, which has been shown to improve running economy and efficiency. It can also help decrease the amount of vertical displacement or bouncing that can occur during the running gait. So this will help decrease the overall amount of force absorbed during the running pattern. So here's our take-home message. If you're dealing with any type of running-related pain or you're looking into buying a new running shoe, you want to get your running gait analyzed. As you can see, where and what hits the ground, as well as what type of footwear you're using, dictates how and where the force is absorbed into your body. Where that force is absorbed is where the highly stressed areas occur. So in addition to a running gait analysis, you also want to have a functional movement screen performed that's specific to you as a runner. That's how we dictate and understand where the force should be absorbed to you, because everyone's individualized. In the example we gave here, if you're trying to transition to a more minimalist style running or forefoot style running, and you haven't met the requirements of calf and Achilles rigidity, stability, strength, you're going to experience an overuse and trauma to that Achilles tendon and possibly the calf. So something that is deemed safe for some may not be right for others. So that's why it's important to have the running gait analysis as well as the functional movement screen. As always, thank you so much for tuning into this post. Feel free to drop a comment below and give us a follow at Thrive Physical Therapy SD. Thanks again.